So before going to transactions, you will see what is the need of transactions. So we saw Spring JDBC, right? Spring JDBC, where we will perform some tasks like local transactions. So there are two types of transactions: local transactions and global transactions. Local transaction, so we will do all the DB operations to one database. Okay, one database. Go the database JDBC transaction. Okay, transactions. Suppose if you see global transaction, right? So there will be multiple databases. Example, I could say like we are going to order a book in Flipkart. Okay, like it will be a Flipkart.com or in Amazon.com. Okay, AMAZON. So once you order, right, it has to flow through different databases. So let's say 5 databases. Here we have something called, okay, here first database, it could be an order system, ordering database, order database, or yeah, DB1, where it's going to put an entry in order table, and DB2, here it is going to put an entry for invoice, what is the price and everything, and then it will put another one. It could have another database table where it is going to put billing address and all those things, and another one database DB3, DB4 for business purpose. For business users, right, they can, for their purpose, they might maintain a separate database. They will log what are the number of products sold, and for stock and everything, stock details, purchase details, and all those things. And here they might have for audit purpose. So one transaction, okay, one DB transaction, nothing like example, we are going to order a book in Amazon. We selected the product. So one transaction which carries the booking information, all those things, right? Booking information and billing details, payment gateway to go, and it will make the transaction there, payment there, and again it comes back. It has to insert in all the 4 database. It's a simple scenario, but in real time, right, there will be a lot of tables involved, to process in global transaction in distributed database applications. Okay, there could be some same databases. Let's see, let's consider. Okay, let's think like this. So let's say this transaction committed the data successfully here. Okay, and here also committed, here committed, and but at this 9th table there was some exception. It is not able to insert properly. It could be exception, could be like data which they send is integer type 1, but that column can varchar type. Okay, but the column can accept only int type, or some persistent character is not good, and there could be some other exception like their column name was what they matched is not good, and or the table might not have a column such like that. Okay, a lot of exceptions which could be thrown. So we want to handle this situation. So all the data which inserted in these tables, right, it will be rolled back. So what we can do is, like, there is something called transaction management API. We have some methods like save point, rollback. So even if it is batch update, we can have some save points. So at this particular point, at this particular after 2 tables, we will have save point 1. Okay, after 2 more tables, we have save point 2, and after 2 more tables, we have save point 3, like that. So if transaction got broken here, okay, so we can roll back to the latest save point. Here there could be some save point like S5. So we can go to this particular point. So all the other data, it will be saved. Again we can perform this transaction, or we can check for log files. Okay, or else we can also roll back to particular save point, go to S1. Okay, so that data will be consistent, and this transaction manager, right? We using that API methods, we can check. So what are the different where the transaction is right now? So whether transaction got completed or it is in between, or yeah, it has any exceptions, it has any save point methods. So all those things we can do actually. So there could be multiple transactions coming in queue. So we can open a transaction and we can perform two. We can have nested transaction and sub transactions and all those things. So we will see that, okay, one by one. There are two types of propagations. We will see here, okay. Like here in this example, right? There is one bean bit.xml, okay. In bit.xml, we are going to get this bean, which we have configured in the spring.xml. So we want to insert a row inside this table, okay. We will check whether how to roll back if any exception occurs, whether we have save point or not, whether the transaction is completed or not. We will try to use few methods from the transaction API, okay. And there is also someone called transaction manager who is going to do everything. So setting the save point and rolling back to the save point, and there are a lot of annotations also in transactions, and mostly in enterprise applications where they will have distributed databases, right? There they use this transaction manager in EJB container, okay. In EJB container, all the transactions in JPA, Java Persistence API, is taken care. So EJB container is going to take care of transaction management, everything, using, if you use JPA entity classes at entity, if you tell at entity, right? So entity object, so all the life cycle of the transactions will be taken care of the EJB container. But here Spring, right? We're not going to deploy it in the EJB container. So it has its own transaction API. We want to configure that. So those transaction manager will take care of handling this exceptions and rolling back to that particular save point and checking whether the transaction is completed or not. Once transaction is completed, finally it will do one task called commit. Once it is committed, that's it. Everything is done. Transaction is completed. Okay, we can also in Hibernate, right? We will use one annotation called transaction. So here we will specify what is the propagation type you want. So let's say there are two transactions. Both the transactions are coming actually. So we can propagate from one transaction. You want to combine both into one unit of work, or you want to split it. So there are different propagation modes. We'll discuss that in Hibernate. But for now, right, just we understand like there is a save point and there are few API methods to check whether transaction got completed or not, or if any exception is thrown, how to roll back to that particular save point, so that we could save some data which has already persisted and all those things. And what are different types? We can do it either in XML way or programmatic transaction declaration or XML declaration. So XML way and programmatic way. So yeah. So here we have transaction manager, which is data source transaction manager, right? You want to give a reference as a database source where we have configured the test database name, root, username, password, everything, and driver manager data source. So this data source transaction manager is going to control everything, creating sessions and creating the save points, rollbacks, and all those things. So yeah. So here we have the student object D, and in this DAO interface we have set create and list methods in student JDBC template, right? So we are going to set it actually. So for this JDBC template, we are going to inject the data source because already we configured, right? So this is JDBC template, right? So in bean.xml we have a bean called JDBC template. Okay. Student JDBC template. For that, so JDBC template, it is going to contain two properties: data source, transaction manager. Yeah, data source, transaction manager. Data source, transaction manager. We have already set it in the bean.xml. Data source is mapped to this bean. It is here setter rejection happens, right? For this data source setter method, we are injecting the data source at one time. We didn't create any instance here equal to new data source. We didn't do anything like that, right? So we injected in the XML file already, and yeah, what is that? Transaction manager also we have injected here to this JDBC template. Transaction manager and here. So these both are setter injections. Right? And then finally we have a main method. From this main method, right? So we are going to create a student, and we are going to get a list of all the students from the database. So here, once you say create, we are going to insert a row into the database, and there is going to be a transaction which is happening in the database. Okay. So here we are going to send first name, last name, and insert statement is here. So we are going to send some, it's a prepared statement, right? So we will pass username, password, and here see these two are very important methods: transaction definition, transaction status. So to this transaction status, we are going to set the transaction definition through transaction manager. Okay, there are a lot of transaction definition, but this is the default one. Using this status, right, we can say whether this method is rollback only, whether it is a new transaction or the transaction is already completed, whether the transaction has any save point. If you want, you can also create save point. Yeah, I want to see here we have one save point, okay, and this save point we are going to set it. We are going to yes roll back to, if any exception occurs, right, it has to go back to this save point, to this particular block. So it is just a local transaction, okay, because I have only MySQL. So in real time, you can conceptually understand, like if it has multiple database connection, then there is going to be a save point, and if you roll back, so we can specify the save points. So one particular cache block, you can say save point 1, save point 2, save point 3, like that. We can roll back to that particular save point. So if any exception occurs here, it will be rolled back. Okay, let us try to run this. And database, we have a table called yeah. You can check whether there is a new transaction. This transaction will completed or not. Yeah, it has a save point. It is going to print the. So actually, I added few SOP statements. Yeah. So it is going to print if whether this transaction has any save point and whether it is a new transaction, it is rollback only. So all those things. So it didn't roll back because the transaction was success. So if any exception occurs, right, it is going to roll back. Let us give one so the table which is not going to exit in database. So some exception will be thrown and it will be rolled back to that particular save point where whatever we inserted, we created. Yeah. So error in creating record, so rolling back. Even if it is new transaction, so then it roll back actually. So yeah, it is not a something like big. So just want to understand like how to roll back and how transaction rollback happens. So how to have a save point. All of them. This is just a simple example. So if you see in global transaction databases, like the distributed databases, that they will handle this using configuration files and annotations. So mostly in Hibernate, right? So there is Spring transaction, Spring JDBC templates transaction. So in Hibernate we have separate transactions. Okay, in Hibernate there are a lot of things about transactions. So we'll discuss more there. Okay, when compared to the space, even same functionality, say point rollback, it's there, but there we use annotations. Everything is annotation driven. So we'll say like there are some tag with tx. So for that I want to add some tags. So you will say mostly using annotations will complete everything actually. So you will scan through all the annotations which is transactional in the class path. So based on that we will configure. We will see that. So yeah, I want to go through the slides so that you get some. So Spring Transaction Management database transactions is a sequence of actions that are treated as a single unit of work. These actions should either completely return or take no effect at all. Once your transaction is beginning, right, it has to be gone to end, and it has to complete all its insertion, everything. Else, it should not take place. So, transaction management is an important part of an RDBC-oriented enterprise application to ensure data integrity and consistency. Actually, atomicity as its property. It should, any transaction, it should fulfill the asset atomicity, consistency, integrity, durability. Okay, so this is what, like, a transaction should be treated as a single unit of operation, which means either entire sequence of operation is successful or unsuccessful. Consistency, this represents consistency of referential integrity of database. So there should be unique primary key in each and every database, so that there won't be any duplicates in accessing the record, and there won't be any foreign key constraints, foreign key integrity constraints. It will not be there. So it has to be normalized and consistent when it comes to an application. So isolation, there may be many transaction processing with same data set at same time. Each transaction should be isolated from other to prevent data corruption. So let's say let's say two applications are there. One application, two users accessing the same record in the database. One is trying to insert the row in the table. At the same time, another user is also trying to insert the row into the same user. There is something called DB versioning. It is going to take care, but in code, right? In code, we should have. So there's going to be two transactions, which is trying to perform insertion on one table. So these two transactions, right? We can make it propagation required equal to new. So even if it has two transactions, it will be queued, and both the transactions will work together and as a single unit of work. Both actions will be combined. There are different transactions, maybe like lesser transactions and inner transactions, and so there comes propagation, whether to make propagation required or propagation new. All those things will take there. So we want to keep transactions isolated, separate one, or you want to combine it into one unit of work, and you want to do as a single transaction in a single transaction. So yeah, to avoid data corruption, once a transaction is completed, the results of this transaction has to be permanent and cannot be erased from database due to system failure. Okay, simplest way of transaction issued to the database using SQL as follows. So there should be begin transaction command. Okay, in the session. So for the session, we will in the channel we are going to open a transaction. In the transaction, we will perform all the update, delete, insert operation using queries. Anything we do on the data, right? Anything we modify a data using the VML commands. If we modify any change to a data, right, then we want to commit it. If it is related to the table, like in table, you are altering the row name, or altering the data type, or altering the column name, or altering the size of the variable, something like that, then you don't want to commit it because it is auto commit. DDL, all the DDLs will be auto committed. So all the DMLs, it needs to be committed in the transaction, else you can't expect the change in the database. So some Spring Framework provides an abstract layer on top of different underlying transaction management API. Spring supports both programmatic and declarative transaction management. EJB requires an application server, but Spring transaction management can be implemented without application. Yeah, EJB, right? It requires EJB container which takes care of transaction lifecycle between the session and database, between the session bean. There are two types of beans, three types of beans: entity bean, session bean, message driven bean, entity bean. So entity bean is responsible for talking to database, persisting the row, reading the row from the database, everything. Okay, updating the row in the database. That entity bean is managed by the EJB container, Enterprise Java Bean container. Enterprise EJB container will scan through all the classes, all the entity beans, and it will take care of it, like creating it, instantiating it, and persisting the row in the database and all those things. But here, right, we are not going to do any entity beans and nothing like that, and we are not going to use EJB container because EJB is heavyweight when compared to Spring, and it has its own transaction management, transaction manager, data source transaction management, also a few other transaction managers there, and they can be implemented without need of any application server. So local versus global transactions are specified to a single transactional resources like JDBC connection. Global transaction can span multiple transactional resources like transactions in a distributed system. So distributed system, like I said, there could be multiple databases, data sources, one for user to maintain the user details alone, username, passwords, and their profile alone, and there could be another database to take care of purchasing and order details, stock details, another database to take care of invoicing and billing, shipment, and all those things. So in such a big application, right, these transactions should be handled very smoothly, else all the data will be corrupted and it will cause a lot of issues. So programmatic and declarative way, programmatic transaction management, it means you have to manage the transaction with help of programming, like implementing the interfaces. There are few interfaces which we need to implement, and there are some lifecycle methods like before transaction and after transaction. Similar to that, we have few lifecycle methods, and using that we want to implement. That gives extreme flexibility, but it's difficult to maintain. Declarative transaction, it means you have separate transaction management from business code. You use annotations or XML based configuration to manage the transactions. So here we use declaration where we declared all the transaction managers, right? We defined the transaction managers here and data source, everything we declared it here. Yes, we are going to, here we have said like this student JDBC template, it is going to use platform transactional manager for who is going to take care of creating a transaction, beginning it, and for this one JDBC template, which has this JDBC template has this transaction manager who is going to take care of inserting, updating, and all those things, committing the transactions and everything, rolling back if any exception occurs. So Spring transaction abstraction org.framework.transaction platform manager. So this platform transaction manager is having a handful of methods like to get the transaction, to commit, and to roll back on the transaction status. This transaction status, it will specially mention like where your transaction is in distributed database connection. So whether your transaction got completed or it rolled back or it has, so in which save point it is right now. Okay, so is it a new transaction, or if it returns false, then means it is already a transaction which exists in database to that particular table, and it is still persisting in few more tables. Okay, even we can use those handful methods, and we can log that to know where our transaction lies. Okay, so transaction definition is the core interface of the transaction support in Spring. It is defined below. Get propagation behavior. So this propagation behavior we will see detail in Hibernate transaction, and get isolation level, get name, get timeout, Boolean is read only. So this we will see. Okay. So okay. Okay. If you take a web application, let's talk about something on why we want Spring validation framework. If you see web application, there will be a client. Client will be nothing but the WSER browser. Okay, and we have server, which will be our web server. Okay, like it could be a Tomcat container of an Apache, or it could be a JBoss, WebLogic, anything it could be. So we will do, and also in Tomcat container we have deployed an application which has 3 layers. One MVC, like model front end layer, front controller, right? Front, and then we will have business layer, right, where we will do all the business validations, and then you might send to the service, you might send to the persistent layer, where we might change some logic on the domain object. Again, we might check whether we need to persist this object or not. So even here, right, we will have some validation check. Validations. And in a front controller also, we might have some validations. Okay. So what we are going to do is, in browser, generally what we will do in browser, we will do like, in browser we will use JavaScript to validate, right? Whether document dot get element by ID, document dot get element by ID, and convert and assign it to a variable, and check if this variable dot size, if it is less than 0, size if it is less than 0, then alert this field is required mandatory, something like that. If you go with jQuery, then there is some attribute like mandatory equal to true, required equal to true, sorry, required, required equal to true. And if they don't enter, they will say required message, something like that, right? So which will required message, so this field is mandatory, something like that we can present to the user. Okay, so let's say it's front end, we have a form, it has username field, and username for first name. Okay, I'll look at first name, last name, address, date of birth, and gender. So what we are going to have is, we are going to tie all these as a property to one object called user object. Okay, let user be an object. Rather than validating at the JavaScript, we are going to validate on the domain object in the server side. So even here, right, we will use this user domain object. I'll make it as devo. Okay, devo, and same devo we will validate in the front also. Same devo we will send it to the business layer and validate here also. And same devo we are going to send it and validate in the persistent layer also. So it is like model. It is like a domain model driven validation. So all the validation is going to take place on this domain model. Okay, we are going to map this front end variable, path variable, to the domain object's property. Okay, and also in database, rather than having a separate table, right, we are going to have a user table with column names as f name and l name and date of birth, same, whatever the property we have in the user object, right, same property we are going, same column name we are going to have in our database. So everything, everywhere in your application, you are going to validate, even in the front end, and even in the controller layer, business layer, everywhere we are going to work. We are going to validate on this domain object, user object. So it is like model driven. We have in the slide we will see that. Okay, so what are the different ways to validate? So it will reduce actually a lot of time if you go with this approach of validating the objects, model objects, right? So it will be object oriented validation. You don't want to have any separate framework.
We do like separate validation on client side, server side, everywhere. Right?
Yeah, so, all the thing it was client side we use JavaScript something, right? JavaScript, jQuery, min.js, and all those things we use.
Yeah.
But rather than doing that, Spring provides validation framework.
Okay.
We want to use Spring tag libraries. Form. There will be, if any errors, we will show the errors. Okay, first I will run that application. Okay. And also we have a lot of annotations which we can use in order to validate the domain object. Okay, I was explaining on this diagram. So old validation solution was here we have JavaScript, and here you might create some other whatever the parameters we pass it right to the presentation layer, like request dot get attribute request in servlet code. We might use request dot get attribute get parameter. We will get all the parameter names, and we might check what is the value of the parameter here in servlet. Again, we will send it to same object, same request to the business layer, or a session entity or a session bean. We might send it to the session bean. There we will do again validation. So rather than doing all that custom validation in each and every layer, what we can do is we can have a domain model in Spring. In Spring, we can have a domain model. Same model we are going to validate here in client side. We will use Spring tag library, and using that whatever the client is going to post, right, post it from Spring tag library from the JSP page. We are going to bind it to this model object. Same model object you will get it here, again here, and also in DB side also we can. Here we have. Here we got, and in web content folder we have that file login form.jsp, and first thing to note here is like we have used such tag library, Spring tag library called form, and here using the Spring tag library we have created two properties, email and password, and here this user form is nothing but it is mapped to this user object. Okay, this user object. In this user object we have few annotations to tell whatever we do in the HTML in JSP page, right? HTML or CSS form, HTML form. We will say like required and required message. Everything we can do it to the class itself directly in the class itself. So there is not empty. This email type, and if the password should be minimum 6 characters, and if it is less than 6 or if it is greater than 15, we will show this message. And even there are a lot of annotations, not empty, not blank, not nullable, number format, and also you can have your own regular expression. You can have this is a form. Okay, I'll submit this. Okay, submit this. It is going to input number format exception. Oh, somewhere I bind it to integer. Number format login controller is here I'm trying to get the integers and put it into because this is employee content integer. Okay, I got it. Okay, I'll stop this. Again, I will go back. Stop this. I'll enter 1. Okay, I'll enter 1. Your email is incorrect. If I enter character less than 6, it will say your password must be 6 to 15 characters. This is the error message which is thrown from the Spring server. Okay, from server it is coming actually. So we were using, here this matters actually. So here we are using Hibernate's validation framework in the Spring. Okay, we have integrated the Hibernate's validation. So all these annotations, right, it is coming from the Hibernate actually, Hibernate's validator framework. So that we are going to bind it to the Spring tag library here. So first, okay, let's go line by line. So first web.xml, right? It will be the entry. So here we have web.xml file, which is this is going to be an MVC project. So we have dispatches already here. So all the requests has to go to this one. So when application context is getting loaded, we are also loading the Spring MVC file. In Spring MVC, we have the beans configured, who is the view resolver, and this message resource is to load the messages, like we can have please enter your email ID, your email ID is incorrect, all those things. If you use this annotation, right, if you use not empty annotation in the user form for email, it is going to present that message. So there are two ways. Directly you can specify here, okay, or you can have a message property and you can set the annotation which object, which bean, and which object, and which to which property you want to show this message. Even that there are two ways. Okay, we have set that. Okay, that we have set it, and message property is also going to load the message property, right? This is fine. So request comes. So this is the default page which we are going to show, because controller, once you click on login, right, it is going to present you login form.jsp. Okay, controller class. If you enter login, right, this URL, it is going to present you login form.jsp. That login form.jsp, here we have it. Login form.jsp, it is presented here. Okay, so here we have used Spring Start library to construct a form. Okay, and we have user form, same user form. We are going, okay, so here we have email ID, password, and let us forget about this error tag form.error with path as email password for now. Okay, but we want to think about this path variable, input path and password path, and this user form. So this user form is going to be the instance of user class, this class, instance of user class, and this email password, if you see, right, property name and it's here the path variable name, both are same. path property name and path variable. Once you click on submit button, you are going to post these two. You are going to bind this password and email to this user form object. Send to the login controller with this action name. Here we have this action name because we are going to post site, so it will pick this URL because it is post method. Both, if you see, right, value are same, but methods are different. First time it is going to be default get method, but now, right, we have posted some login form. We have posted some form, email and password. So it will pick this method. Here, this is very important part. At valid model attribute binding result and model. Okay, this is not big deal, but binding result valid annotation and binding result class is very important. So this means this valid annotation from the Hibernate, from the JavaX validation framework is very important, which means like it is going to validate the user form, whatever the user has sent, right? Whatever the user has sent, this model attribute will contain the path, username and password. It is going to map it to this user object and it is going to validate. Once validated, it is going to give the result to this object. Binding result. What is the result after validating the model attribute to this user object? If it is not null, if it is null, email if it is empty, or if the string if it is less than 6 and if it is greater than 15, then validation fails, right? So this validation fails. So this binding result, right, it is going to contain error. It is going to contain some error tag, error information. So that's what we are checking here. If the result, binding result, has any errors, again present in the login form.jsp, else you present in the login success.jsp. And using this model map, you can also add some values to it, and you can send it to the even both this model object, right? You can get it in both login form and login success page. Okay, so that's what we are getting this message. So if I try to give proper, so now email ID is still incorrect. I want to give proper format. Now it comes to, so this is what we have set right here. So login controller, here we are setting the password, username password to this employee key, and this is going to be the value. Password is going to be the value. So this model we will get it in the login success page. So in the login success page, if you open and see, we are getting the user form dot email and employee expression language. So that is what we are able to see. This welcome page. This is the user email ID and user name, email ID, and there's a password whatever he entered. Okay, so here everything is model driven. So we are using Spring validation, Spring integrated with the validation framework of the Hibernate in order to validate the form. So so we are binding whatever the form, right? We are going to bind it to the object's property, so that same user object you can send it to the service layer, business layer, and also in the persistent layer. Even in the persistent layer, right, we will have an entity class called user, which will be mapped to the table. So that user will say session dot save user. That's it. It will be saved to the database. So everything is going to be the domain model. So we will discuss about this slide once again. Okay, there are a lot of things like you can also have, you can create your own custom you can create your own custom annotations, like not null, right? I'll show one example, but we will discuss all those things tomorrow. So here I'll create one annotation. Interface. Custom email ID. Okay, it is going to be an annotation. This annotation will contain, I can specify everything here, not null, sorry, not null, right? Not null, not empty, not blank, not null, size, min 10, max 50, required message. This is custom email validation. This and then this, and I can specify this directly to the. I don't want to write this one. Okay, I don't want to write this one directly. I can use that annotation. That's it. So we can create our own custom annotations also. We can tell like it's an email. Even this will work. So we can create our own custom annotations based on the field, which is even not possible in JavaScript, right? We can have we can define some interfaces, right? We can define some interfaces. Everything we can declare here, and we can create a class which implements the interface. There we can define our own custom logics, and we can validate the form.